So proc ANOVA is designed to handle balanced data. That means it has equal number of observations for all combinations of categorical data. The one way ANOVA is that's basically one treatment with predictors with multiple levels. That's one way ANOVA. The assumptions that we make in ANOVA analysis is that that the treatment effects are additive. The experimental errors are independently random. With the normal distribution. N of 0 sigma square. So the bacteria strain, this is just an example, will have, let's say, like 6 levels, and its effect is calculated on the nitrogen level. In milligrams. So this is just an example that you can think of. So if that is the case, then how do you write proc ANOVA? So proc ANOVA data equal to clover, class strain model, nitrogen equal to strain, run. That's the SAS code that you will be writing it down. The other thing you can write is you can write proc ANOVA data equal to clover class strain, mean strain divided by Tukey model, nitrogen equal to strain. This one is basically a strain levels with the Tukey's studentized range procedure. And then you run it basically. So the degree of freedom that you are providing over here is basically n-1. So that's an important thing to look at. The other thing we can talk about is something called a randomized complete block, with the one factor. Randomized complete block with one factor, which is nothing but a proc ANOVA. It's a randomized complete block design, experimental units are not homogeneous. They're not homogeneous. So the effect of different treatments treatments. It can will be evaluated on the response variable, right? That's what we are trying to do. So the example could be, let's say you can write proc and ANOVA data equal to RCB class block treatment model yield worth equal to block treatment. Okay, so this could be written as a continuous response variable, and this one would be categorical classification variables. Okay, just write it as run here. So the degree of freedom, if you look at it, will be b minus 1 plus t minus 1. Okay, where b is nothing but number of block levels, and t is nothing but number of treatment levels. Okay, so those are the things that you have to keep in mind. The other thing you can also talk about is something called randomized complete block with factorial treatment. Okay, factorial treatment. So randomized with let's say you are doing a randomized block with two treatments. Okay, with two treatments or two treatment factors. They might have something called the occurring in a factorial, occurring in a factorial structure. Okay, so in order to write this down, you'll have to use proc ANOVA data equal to pain relief class pain level codine, let's say acupuncture model relief equal to pain level codine acupuncture. Okay, run. So the alternative multiple comparison procedures. So that you can actually write it down as proc ANOVA data equal to clover class strain model nitrogen equal to strain mean strain 2 chi run. Okay, where again those are some of the things that you can actually write down. What else can we do? Those are the only things. I think that's about it. I don't think there's anything other than that. We'll talk about the split plot and other different types of procedures on the next section, or maybe we can cover it over here. I don't think there is anything much to talk about. I think those probably would be the last thing that I can talk about. So let me just talk about something called the split plot. Okay, the split plot is basically used in a nested grouping of observations. Okay, so you can write that down as proc ANOVA data equal to split class block AB model response equal to block A block AB and AB. Okay, test H equal to A, E equal to block into A. Okay, run. This would be the F test of the A effect. Okay, which uses block into A effect as the error term. Okay, whereas over here the B defines subplot without block into A, like the whole plot, the whole plots. Okay, so that's what it is. The other thing we can talk about is something called the Latin square split plot. Okay, which is nothing but a proc ANOVA data equal to beats class column rep variety harvest model y equal to rep column variety rep into column the variety harvest into rep harvest to variety. Okay, test H equal to rep column variety equal to rep into column into variety. Okay, test H harvest equal to harvest into rep run. Okay, so that's how we actually write the. So the procedure that we use in SAS is something called proc and ANOVA, and you have a lot of options. Those options you will be available to you in the documentation, and then you write class and then the variables. Again, you'll have a lot of other options that you can choose from. Okay, and then you have to write the model and then the dependent equal to effects. Okay, and then a lot of options. You can also put observe as an option here, which is nothing but observe variables. This would be observe class of x, okay, in a model. Okay, and then you say by variables. Okay, this will basically it specifies variable to define subgroups, okay, for the analysis. Okay, and then you can also write frequency, variable list. You can do multivariate analysis as well. There is an option within proc ANOVA. It's again for multivariate analysis of variance. Okay, so you can perform that, but for that you need, again, you have test options, and you have detail options. Okay, and then we can write means, effects, options, repeated, factor, specifications. Again, a lot of different options. And you have the test, the edge effects. Okay, again, the E effects. So again, for repeated, it's basically to perform something called the multivariate and univariate repeated measures analysis of variance. Okay, and then on the test side, you basically construct tests that use the sums of squares for effects and error term you specify. Okay, so that those are the things that you need to know in proc ANOVA. Okay, now so how do you do the analysis? There are certain examples that I can give you. Let's say you can write as proc ANOVA class, let's say A and B. You can model y1 minus y5, A and B of A. You can do multivariate analysis as well with n equal to A, E equal to B of A, and print H, print E. ANOVA and B of A, print E. ANOVA n of A, E is equal to B of A, M is equal to y1 minus y2, y2 minus y3, y3 minus y4, y4 minus y5. Okay, prefix equal to difference, where you can write ANOVA n equal to A, E equal to B of A, M is equal to 1 minus 1 0 0 0, 0 minus 0 1 minus 1 0 0, 0 0 1 minus 1 0 0 0 0 1 minus 1. Okay, the prefix equal to difference, and yeah, you have to put it on at the end. Okay, so that's one example. The other way you can write ANOVA is proc ANOVA class group. Okay, model dose 1 minus dose 4 is equal to group uni. Okay, ANOVA H is equal to group, M is equal to minus 3 into dose 1, dose 2, dose 3, and then dose 4, dose 1 minus dose 2 minus dose 3 plus dose 4 minus dose 1, dose 2, dose 3, and dose 4. Okay. M names equal to linear, quadratic, cubic. Print, and then you use the run. Okay, so that's another way of looking at it. So those are the things that you can think about. So basically, again, ANOVA model basically specifies effects. Okay, which is nothing but combination of class variables, okay, which has effect on the dependent variable, right? And it has effects or variability, correct? So the effects could be, there is going to be a main effect that might be present, so A, B, and C. There could be a cross effects, right, such as A intersection intersection B, A intersection C, A intersection B, C, right? And then you could have a nested effect, right? So like B of A and C with D of A and B. Okay, so those are also possible to write in proc ANOVA statement. So for main effects, you could write it as proc ANOVA class A, B, and C model y is equal to A, B, and C, and then you can run it, right? For the cross effect, you can write proc ANOVA, right, class A, B, and C model y is equal to A, B, C, A interaction B, A interaction C, B interaction C, and A interaction B interaction C. Run. Yeah, the bar, there is something called again bar notation. You can use bar notation too in ANOVA. Sorry, analysis of variance. So it's proc ANOVA class A, B, and C model y equal to A, B, and C. These are basically again full factorial models, and then you can use the run statement.